fellow students. Today we are going to discuss about open chain structure of glucose. We studied about classification of carbohydrates in our previous lecture. Okay, glucose. Glucose occur in the nature in free state as well as in the combined state. Glucose mainly found in the ripe grapes. That's why it is called as grape sugar. Commonly it is called as grape sugar. Glucose is an example of aldohexose. Which means that one aldehyde group with 6 carbon atom. It contains one aldehyde group and 6 carbon atom in the chain. And the structure of glucose was given by Bayer. And according to that structure, it contains one aldehyde group, one primary alcoholic group, and 4 secondary alcoholic group. C double bond O H, one aldehyde group, CH OH 4 times, and CH2 OH. In this, one aldehyde group is present and 4 secondary alcoholic groups are present and one primary alcoholic group is there. Okay? Now the question is that what is the meaning of primary and secondary? Primary alcoholic group, it means that hydroxyl group is present on the primary carbon atom, and secondary alcoholic group, it means that the alcoholic group, it is present on the carbon which is secondary, and primary carbon is that carbon which attaches to one side from the carbon, and secondary carbon, which it means that it attaches to the 2 carbon atom, or we can say that it forms the 2 bonds with the carbon atom, then it is called secondary. And if hydroxyl group is present on the secondary carbon, then it is called as secondary alcoholic group. And students, this open chain structure of glucose was assigned on the basis of some evidences or chemical reactions. And now I am going to discuss that evidences or the chemical reactions which proves the chemical structural representation of glucose. Hence, glucose, the molecular formula of glucose is C6H12O6. And in glucose, all the carbon atoms are present in straight chain. And when this glucose heated with Hi in presence of red phosphorus, then it gives N-hexane, CH3, CH2 4 times, CH3. When glucose is heated with HI in presence of red phosphorus, then it gives N-hexane. And in hexane, all the carbon atoms are present in straight chain. And this reaction proves that all the carbon atoms are present in straight chain. And students, Remember that H in presence of red phosphorus. It is the strongest reducing agent. And Hi in red phosphorus, it is the strongest reducing agent. It reduces alcohol, aldehyde, carboxylic acid. Okay, it is a very powerful reducing agent. Okay, and when glucose is heated with hydroxylamine NH2OH, then it forms oxime with the loss of water molecule. CH double bond N OH, CH OH 4 times, CH2OH. This part remain unaffected when glucose treated with hydroxylamine, then it reacts with carbonyl group. This is a carbonyl group and it forms oxime. And similarly, when it reacts with HCN, hydrogen cyanide, then formation of cyanohydrin takes place, and these two reactions suggest that glucose contains one carbonyl group. And students, when this glucose treated with a mild oxidizing agent like bromine water, then it gives gluconic acid containing the same 6 carbon atoms as present in glucose. This aldehyde group is converted into carboxylic group. And the formation of gluconic acid with the reaction with bromine water proves that carbonyl group which is present in glucose is an aldehyde group. This reaction proves that carbonyl group is an aldehyde group. As bromine water is a mild oxidizing agent, it oxidizes only the aldehyde, not the ketones. Okay? And when glucose treated with acidic anhydride group, then formation of pentaacetate take place. CH O COCH3 again COCH3 similarly. Formation of pentaacetate confirms that glucose contains 5 hydroxyl carbon atom makes the molecule unstable. Now, glucose is a stable compound. Therefore, 5 OH group must be present on different carbon atom. So, this reaction proves that it contains 5 hydroxyl groups. Okay? And the presence of one primary hydroxyl group was suggested when it is treated with concentrated nitric acid. Concentrated nitric acid, which is a strong oxidizing agent. It can oxidize carbonyl group as well as primary hydroxyl group. And the oxidation of secondary alcoholic group is quite difficult. So, when concentrated nitric acid reacts with glucose, then it forms saccharic acid. Formation of saccharic acid take place. And this reaction proves that it contains one primary hydroxyl group. Okay?